अस्सलाम वालेकुम व्यूवर्स। उम्मीद करता हूँ आप सब खैरियत से होंगे। आज हम मैथमेटिकल मेथड्स ऑफ फिज़िक्स की सीरीज़ की शुरुआत करने जा रहे हैं, जिसमें आज हम डिफरेंशियल इक्वेशन पर बात करेंगे। एन इक्वेशन इन्वॉल्विंग डेरिवेटिव्स इज कॉल्ड अ डिफरेंशियल इक्वेशन। फॉर एग्जांपल ए डी स्क्वायर वाई बाई डी एक्स स्क्वायर प्लस बी डी वाई बाई डी एक्स प्लस सी। यहाँ पर एक टर्म मिसिंग है वाई। सी ऑफ वाई इज इक्वल्स टू पी ऑफ वाई। So p of y is any function of y, and a, b, c are the coefficients of the derivatives of the y. So कोई भी ऐसी इक्वेशन जिसको हम इस फॉर्म में लिख सकते हैं उसे हम डिफरेंशियल इक्वेशन कहते हैं। And the differential equation are of two types: ordinary differential equation and partial differential equation. Ordinary differential equation is one that involving ordinary derivatives or complete derivatives is called ordinary differential equation. For example, a d square y by dx square plus b dy by dx plus c into y is equals to p of y, where y is just only derivated with respect to a single variable y. So it is an example of ordinary differential equation. And now, the partial differential equation is one that involving partial derivatives or incomplete derivatives is called partial differential equation. For example, a partial square y by partial x square plus b partial y by partial x plus c into y is equals to p of y, where y is not only be just a derivative with respect to x, it is derivated with respect to some other variable, so it is incomplete derivative. So it is an example of partial differential equation. And now, the order of the differential equation is the highest derivative of the differential equation is called the order of the differential equation. For example, as our general equation is a d square y by dx square plus b dy by dx plus c is equals to p of y, in which the highest derivative is 2, so the order of the differential equation is 2. But the degree of the differential equation is one that having the power of the highest derivative. So the power of the highest derivative of the this equation is 1, so the degree of this differential equation is 1. Now, the homogeneous second order ordinary differential equation. If p of y is equals to 0 of equation number 1 and it has highest second order ordinary derivative, then the equation is called as homogeneous second order ordinary differential equation. If we equate p of y is equals to 0, then the general equation become an homogeneous second order ordinary differential equation as given. Equation A as a d square y by dx square plus b dy by dx plus c into y is equals to 0. So now moving forward, as the solution of the homogeneous second order ordinary differential equation, as the roots of the quadratic equation are the solution of the equation that satisfies the quadratic equation, as for example x square plus 2x plus 3 is equals to 0. And then the roots of the quadratic equation are real or complex, but the roots of the ordinary differential equation may be real, complex, or it can involve any function, as the examples of the homogeneous differential equations are a d square y by dx square plus b dy by dx plus c into y is equals to 0. And other example is 1 minus y square d square y by dx square plus b dy by dx plus c of y is equals to 0. These two are the examples of the homogeneous differential equation. And now look at an example, as let's let's take a homogeneous second order ordinary differential equation with constant coefficients, as a b c are the constant coefficients. So a d square y by dx square plus b dy by dx plus c of y c into y is equals to 0. So now now making its firstly its characteristic equation, and by solving it we obtained as y is equals to e gamma x. Now and we generally knowing this uh, term as guess function. So let consider a guess function that satisfies the above equation as y is equals to e or of x or into x. Now let's check that if this solution satisfies the equation A, it becomes the root or not. So by putting this in equation number 1 as or required equation A, so we obtained as so AD square y by dx square E Rx plus B dy by dx E Rx plus C E Rx is equals to 0. So by solving we obtain as the characteristic equation as AR square plus BR plus C is equals to 0. So by solving further we obtained as R is equals to minus B plus minus B square minus 4AC square root by 2A. So the discriminant can be obtained by B square minus 4AC. So we have two roots of the quadratic formula. Then let's check the nature of the roots. If b square minus 4ac is greater than 0, then the roots are the real and distinct, as r1 is alpha and r2 is beta. So as alpha and beta are real numbers, and the solution will be y1 is equals to c1 e alpha x and y2 is equals to c2 e beta x. And the general solution is y is equals to y1 plus y2. So y is equals to c1 e key alpha x plus c2 e beta x. This is the general solution of this type of roots. So now if b square minus 4ac is equals to 0, then the roots will be equal and non-distinct or similar. As we know, as we equating r1 is alpha and r2 is again alpha, then solution will be of this kind, as y1 is equals to c1 e key alpha x and y2 is equal to c2 x e key alpha x. So the general equation is y is equal to y1 plus y2 is equals to c1 e key alpha x plus c2 x e key alpha x. And now moving third type, as if b square minus 4 is less than 0, then the roots are complex, as r1 is alpha plus iota beta and r2 is alpha minus iota beta. So solutions are y1 is equals to c1 e key alpha plus iota beta into x, and y2 is equals to c2 e key alpha minus iota beta into x. And so the general equation is r1 as alpha plus iota beta and r2 is alpha minus iota beta. So y1 is equals to c1 into exponential alpha plus iota beta into x plus dot sorry y1 is equals to c1 e exponential alpha plus iota beta into x, and y2 is equals to c2 e alpha minus iota beta into x. So the general equation is y is equals to y1 plus y2. So y1 is equals to c1 e key alpha plus iota beta into x plus c2 exponential alpha minus iota beta into x. This is an general equation. And if the roots are similar and complex, as r1 is equals to alpha plus iota beta and r2 is equals to alpha plus iota beta, then the general equation is become as y is equals to c1 exponential alpha plus iota beta into x plus c2x exponential alpha plus iota beta into x. As example, as 2d square x plus, by dt square minus 6 dx by dt minus 4x is equals to 0. Let the guess solution is y is equals to e exponential rx. So its characteristic equation is ar square plus br plus c is equals to 0. So putting the values of a, b and c as 2r square plus into minus 6 into r minus 4 is equals to 0. So 2r square minus 6r minus 4 is equals to 0. So the by quadratic formula we can find its roots as r1 is equals to 3 plus square root of 17 by 2, and r2 is equals to 3 minus 17 square root by 2. So its a solution or can be of y1 is equals to c1 exponential of 3 plus square root 17 by 2 into x, and y2 is equals to c2 exponential of 3 minus square root of 17 by 2 into x. So the general solution will be y is equals to c1 exponential of 3 plus square root 17 by 2 into x plus c2 exponential of 3 minus 17 square root 17 by 2 into x is equals to